So this was a weekly pop quiz. You can mention your doubts. The first pop quiz, which was related to the MCQs. Any doubt in question one? Question one, any doubt? Question two, three, any doubt? Question two or question three, any doubt? This is a weekly pop quiz. If you have doubt, you can mention your doubt. Question four, five, any doubt? Question four or question five? Question four? Okay. In question four, in the circuit shown, an analog ammeter is to be recalibrated as a thermometer. The ammeter is connected in series with a thermistor. The thermistor is a component with a resistance that varies with temperature. The graph shows how the resistance R of a thermistor changes with the temperature. Which diagram could represent the temperature scale of an ammeter? First, what is the relation here? It shows that when the temperature is increasing, the resistance is decreasing because thermistor is a semiconductor. So when we increase the temperature, the resistance of the thermistor will decrease. Now, when we calibrate this scale, like when we write the number from 0 to 100 are written. So if we divide evenly, so means this will be 50. So this will be 10, 20, 30, 40, and then 60, 70, 80, and 90. So when you see this change, the relation between the temperature, because the numbers which are mentioned here, the 20 is there, the 40 is labeled, the 60 is labeled, 80 is labeled, and 100 is also labeled. When you compare the change, in the beginning, the resistance is changing at a greater rate. As you can see, it's much steeper. But later, from 20 to 100, the change in the resistance is smaller because on y-axis we have the resistance. So when the temperature changes from 0 to 20, about 20, there's a drastic change in the resistance. But when the temperature changes from 20 to 100, there's a small change in the resistance. So which scale is showing the drastic change? Like as you can see, from 0 to 20, there's a large change, but from 20 to 100, there is a relatively smaller change. So that's why A will be the right answer. Why C and D are wrong? Because C and D, the scales, when an analog ammeter is there, it should start. The rule is that for an analog ammeters, it will always start. The left-hand side, we always have a 0. So C and D does not choose the pointer correctly. That's why it is wrong. So either B can be an answer or A. But what happened in B? That from 0 to 20, when the temperature changes from 0 to 20, the change in the resistance is small. But from 20 to 100, there's a large change, according to B. But according to the graph, when there's a change in the temperature from 0 to 20, there's a large change in the resistance as compared to from 20 to 100. Is it clear, this one? Question 5, 6, any doubt? Question 7, 8, question 6. In question 6, a tennis ball falls freely in air. So whenever object is dropped from a certain height, and these are the distance time graph, when object is dropped from a certain height, what happened to its velocity? Its velocity will increase. And then eventually what will happen? When the weight and air resistance are balanced, the velocity will be constant. So we have a distance time graph. The distance time graph, what slope represent? The slope represent the speed. So first the velocity is increasing, so slope should increase. The first part of the motion, the slope should increase, and then the velocity is constant because the air resistance balance with the weight. So it will move at a terminal velocity. In that case, A will be the right answer. So for falling objects with air, initially the speed will increase, so it will accelerate, and then the acceleration will be zero. It will move at a constant speed. Question 7 or 8, any doubt? Question 7 or question 8? Question 8, okay. In question 8, the momentum of a car of mass m increases from P1 to P2. What is the increase in kinetic energy? First, we'll try to write a formula, the relation between the kinetic energy and the momentum. Look, the formula for the kinetic energy Ek is equals to half mv square. This is the formula for the kinetic energy. If I multiply and divide this equation by m, so it will become 1 by 2 mv square multiplied by m and divided by m. Because if I multiply and divide by m, it does not make a difference. So if I multiply and divide by m, there is no difference here. So when I simplify, it will become Ek is equals to half. This m is multiplied with m, so it will become m square v square divided by m. What is m square v square? M square v square is momentum square. Because m into v is the momentum, so m square v square is a momentum square. So in place of m square v square, I can say momentum square. So I can write a formula that Ek, the kinetic energy, is equals to p square divided by 2m. So this is a formula which relate the kinetic energy with momentum. It's a fixed formula. You can learn this formula as well, or you can derive that the kinetic energy is always the momentum square divided by 2m. Why we multiply? No, because I want to convert, as I want the relation between the kinetic energy and the momentum. So when I write a kinetic energy which is half mv square, so how I can make this momentum? How I can convert this m into v into momentum, m into v square into momentum? That's why I multiply and divide it by m. So that when m multiplied with m, it will become m square v square divided by m and Ek. And m square v square is the momentum square divided by 2m. Why not only multiplied by m? Because if I multiply mathematically, for example, if I say x is equals to y plus 2, mathematical equation, because this is a equation, if I only say I multiply this by 4, this will be wrong. Because whenever a mathematical equation, I want to apply any operation, so I should apply an operation which will not change the equality. So how equality will not change? If I multiply by 4, then I should divide by 4 as well. Then only the equality of the equation does not change. Otherwise, if I only multiply by m, the equality will change. So in short, the relation between the kinetic energy and the momentum, that the momentum square divided by 2m, that is equals to kinetic energy. So a car of mass m increases from P1 momentum to P2. What is the increase in the kinetic energy? The equality, when I mean equality, like example, when you have an equation, say in equation it is written x is equals to y plus 2. So if I want to multiply this equation by 4, then I have to divide this by 4 as well. Why? So that this relation will not change. Otherwise, if I only multiply this by 4, the relation of the equation will change. It will no longer be equal. So that's, I mean that the equality of this equation will change. It won't be equal again. So if we have the kinetic energy, which is Ek, and that is equals to half mv square. So what I did, if I multiply this by m, I will multiply the other side also by m, so that the equality remain true, like the equal to stay at it as it is. So this will be m Ek, then m multiplied by m, it will become m square v square, and m square v square is a momentum square, and that is m into Ek. So when I work out Ek, the kinetic energy, it is p square by 2m. So that's a formula. Now, this object which was having a mass m and it was having a momentum p1. So what is the kinetic energy here? The Ek, that is p1 square divided by 2m. Then it changes the momentum. The new momentum is p2 and the mass remains the m. So the kinetic energy now will be p2 square divided by 2m. The question is, what is the increase in the kinetic energy? How much kinetic energy has increased? So if I want to work out the increase in kinetic energy, I just have to take a difference of the two values, the kinetic energy before and kinetic energy after. When I take the difference of the two values, I'll get the increase in the kinetic energy. So this was a kinetic energy after, and this is a kinetic energy initial. So I will take a difference of p2 square divided by 2m minus p1 square divided by 2m. The 2m will be the LCM. So it will be p2 square minus p1 square. So it matches with option A. Is it clear, this one? No, B, why B is not same as A? Because no, there is a difference between, there's a big difference between x minus 1 whole square and x square minus y square. This is individual square subtraction divided by 2m. This is a whole square subtraction, then square. So they are not equal. Because x square minus y square, in maths, this is equivalent to x minus y and x plus y. So that which is not equal to x minus y whole square. They are not equal at all. So the difference is that this is an individual square subtraction and this is a whole square subtraction. So first momentum, individual momentum square, that was the first kinetic energy. The individual momentum square divided by 2, that's the second kinetic energy. And when we subtract, so we got the final momentum square minus the initial momentum square divided by 2m. But this is not equivalent to the subtraction whole square divided by 2m. This is totally different. Question 9, 10, any doubt? Question 9 and 10. Question 10. In question 10, a horizontal metal bar PQ, which is 50 centimeter, is hinged at an end P. Question 9 first, okay. In question 9, two similar spheres, each of mass m and traveling with a velocity v, are moving towards each other. Look, what is, because it should follow a conservation of the momentum, the total momentum before must be equals to total momentum after. Or the kinetic energy before should be equals to kinetic energy after, because they mention it is an elastic collision. So if we talk about the momentum, what is the momentum of this one? It will be mv. What is the momentum of this one? It will be minus mv. Why? Because it is in opposite direction. So what is the total momentum before? The total momentum before is 0. So total momentum after should also be 0. Means when these objects collide with each other, when these objects collide with each other, they will stop after collision. So which statement is correct? The spheres stick together on impact. When we say the stairs, like, or when they collide with each other, they will bounce back because the collision is elastic. Like, this is a momentarily, they will not stop completely. Momentarily, when they hit, they will stop and then they will move in opposite direction. Why they should move in opposite direction? Because the momentum should be conserved and the kinetic energy is also should be conserved. As I mentioned, it's an elastic collision. So momentum can be conserved if they stop or they recoil. The momentum will be conserved because the total momentum is zero. The final should also be zero. But if they stop after hitting each other, the kinetic energy will not be conserved. Why the kinetic energy will not be conserved? Because the kinetic energy of the first one is half mv square and the kinetic energy of the second one is also half mv square. So the total kinetic energy will be mv square before. So the total kinetic energy after the impact, after they collide, should also be mv square. But if they stop, means the total kinetic energy is zero. So which is wrong because the collision is elastic. So final kinetic energy should also be mv square. When we check option B, the total kinetic energy after the impact should be mv square. That's true because the total kinetic energy before is mv square. So when they recoil, they move back. The total kinetic energy after should also be mv square. And why? Because the collision is elastic collision. So whenever there's an elastic collision, the kinetic energy before must be equals to kinetic energy after. The total kinetic energy before the impact is zero. That's wrong. It is mv square. And the total momentum before the impact is 2 mv. That's also wrong. The total momentum is zero before the impact as the two objects have the same mass, but they are moving in opposite directions. So the momentum should be conserved. So the total is mv minus mv, which is zero. So B is the right answer for this. Is it clear, this one? In question 10, the horizontal metal bar PQ of a length 50 centimeter is hinged at the end. The diagram shows a metal bar viewed from the above. The two forces are 16 Newton and a 5 Newton. So if this is a pivot, this 5 Newton will cause a clockwise turning effect and this 16 Newton will cause an anti-clockwise turning effect. But whenever we take the force, we always take the perpendicular, like the distance between the force and the angle between the force and the distance should be 90. So this 16 will have the two component. One of the component is with an angle. So this is equals to 16 cosine 30. And another component will be the perpendicular, which is equals to 16 sine 30. So the clockwise, and what is the total moment about P? So what is the moment, the clockwise moment? So this will be 5. 5 is the force. And the distance from the pivot, which is 50 or equals to 0.5. So when we multiply, we got 2.5 Newton meter. That's the clockwise. What about the anti-clockwise turning effect? This will be 16 sine 30 times 0.5 because the distance from the pivot is 0.5. Which is equals to 16. Yeah. So this is equals to 4, I think, 4 Newton meter when you simplify this. So this one is 4, which is anti-clockwise. Another one is there, which is 2.5 clockwise. We want the result because the two moments are in opposite direction. When two moments are in opposite direction, if we want the result, we will subtract them. So 4 Newton meter minus 2.5 Newton meter. So the result will be 1.5 Newton meter. Question 11 or 12, any doubt? Question 11, 12, any doubt? Question 11. In question 11, we need block P, Q, R, and S are made from a same material of same density, but T is made from a material which is twice dense. The cross-sectional areas and the heights are shown. Which two blocks exerts the same pressure on the ground? So if you want to calculate the pressure, pressure is force acting on unit area. For the blocks, because the force which they are applying on the ground is equals to their weight. So it will be weight divided by area. But weight, how we can represent in terms of the, because W equals mg, so we can write mass into gravity divided by area. And how we can represent the mass in terms of the density, that density is mass over volume. So mass will be density times volume. So in place of mass, we can write density into volume. So density into volume into gravity divided by area will give us the pressure. So pressure will be equals to density times volume times gravity divided by area. Now we will check for individual, like let's check for P. So the pressure exerted by the P is equals to density into volume into gravity divided by area. So the density is example, we can say D or rho you can also use. So density is D example, or rho, you can also use rho here. The volume, what about the volume? Volume is area multiplied by height. So volume will be A into H because the base area is A and the height is H. So volume is area multiplied by height divided by multiplied by G and divided by the base area because we need the pressure. Pressure is force acting on unit area. So density into area into height into gravity divided by area. So when we simplify, so what is the pressure exerted? What is the pressure exerted by P? The pressure exerted by P is equals to D, the density, the height, and G. That is the expression for pressure by P. If you want to work out the pressure by this second object, its density is D. It's A. What about the volume? The volume is area multiplied by height. So area is 2A and the height is H into gravity divided by area, which is 2A. So 2A will cancel with 2A. So what we are left with, it will be D, the density, into H into G. So it means P and Q will exert the same pressure, but we don't have any option which P and Q are together. When we check this third one, the R. So when we check for R, the density is D, the area is A, and the height is 2H into gravity divided by area is A. Area will cancel with area. So what is the pressure exerted? Density into 2Hg. That's the pressure it will exert. What about S? The density is D. The area is 2A. The height is 2H into gravity divided by area is 2A. So 2A will cancel with 2A. So it will be D. So when we compare, so this will be density, the 2Hg. So means R and S will exert the same pressure. Look, the pressure exerted depends on the force, depends on the area. Because they have the same density, their area and heights are different. So their mass will be different. So the force will be different. So you don't compare only with the area, you have to compare the mass as well. And the last one, the density is 2D, the area is A, and the height is H into gravity divided by area. Area will cancel with area. So it will be 2. Like if you simplify, it will be D 2Hg. So means the pressure exerted by R, S, and T will be same, and the pressure exerted by P and Q will be same. Now, when we check the options, P and T, this P and T, are they exert same pressure? No, they're exerting different pressure, so this is not correct. Q and R, Q compare with R, so it's different pressure. When we compare Q and S, again it is different pressure. But when we compare S with T, it is the same pressure, so D will be the right answer. So not only the pressure exerted by the object depends on the force, it also depends on the area combination. And in this case, the force was density into volume into gravity divided by area. So that's how we apply the rule and work out which one give the same expression that exert the same pressure. So you just don't compare the area, you have to compare the density and the volume as well. Yeah, if the height and the densities are same, then only the pressure will be the factor that will affect. Then the area will be the factor that will affect the pressure. If the heights and the densities were same, in that case, yes, area we'll compare the area. But because here the heights were changing, the areas were also changing. So it means that the densities were also different. So we'll compare the masses as well. Is it clear, this one? So just remember this formula whenever you want to compare the pressure exerted by the solid with different areas, different heights, different densities. So it will be density into volume into gravity divided by area. If you want to compare the pressure. Question 12, any doubt? 12, 13, 14, 15, any doubt? Question 16 or 17, any doubt? Question 17? Question 16, okay. Question 16, an aircraft travel at a constant velocity. So if the aircraft is traveling at a constant velocity, the thrust should balance with the drag. So it should be 2400 newtons. We need the power produced. Remember, I just give you an idea about the power. There's another formula for power, that is force multiplied by velocity. This force is not the resultant force. This is a force which is required to maintain a constant velocity. And V is the constant velocity. So if I need the power of the engine, the thrust of the engine, the force of the engine is how much? Because if the drag is 2400, the thrust should also be 2400. And the speed at which this aircraft is moving, that is 90. So 2400 into 90, when you multiply, what you will get? The product. So 2400 multiplied by 90. To 2.2 exponent 5, 21,000. Okay, 216,000 watts, which will be if we round off, like example, 2.16 into 10 to the power 5 watts, which is approximately equals to 2.2 exponent 5 watts. In question 17, the electrical generator is started at a time 0. Total electrical energy is generated during the first 5 seconds in the graph. What is the maximum electrical power? Look, how to get the power from energy and time. As I mentioned, the slope of the graph is a quantity on y-axis divided by quantity on x-axis. So on y-axis, I have energy. On x-axis, I have time. Energy divided by time will give us the power. So means the slope is actually, slope of this graph is representing the power. The question is maximum electrical power. So maximum power means maximum slope. So which region of a graph I have a maximum slope? Is it A to B, B to C, C to D, or D to E? Which region I have a maximum slope? So which region of a graph I'm having a maximum slope? So I have a maximum slope from C to D. So I will just work out the power in this region. I will work out the slope of this region, and that will give us a maximum power. So how to work out the slope? You can use, like, this will be x1, this will be x2, this will be y1, and then y2. And use a formula for the gradient, which is y2 minus y1 over x2 minus x1. So y2 was 40, y1 is 10, x2 is 3, and x1 is 2. So it will be 30 divided by 1, which is equals to 30. So we'll get C as a right answer. So what you have to check the slope of the graph, because the energy divided by the graph between the energy and the time, the slope represent the electrical power or the power here. Because they asked for the maximum, that's why we took the maximum gradient. Any other doubt? This was a pop quiz 1. Any other question or doubt from this pop quiz?